We're gonna take two on the practice set, systems of equations by graphing. A typo in one of the problems led to a not great outcome. So hopefully we have fixed that. Please like and subscribe if you find this video helpful, and check out the other videos and playlists on the channel. And without further ado, please pause the video to work these problems on your own, and then come back to check your work. Right, so for this first problem, what we are going to do is do this out entirely by hand. And I have absolutely no idea why we have some blue dots over there. That is weird that they're there, but just we're going to ignore them. And what I want to do with this problem is everything by hand. So no hocus pocus, hey, I solved it for y. No, here's my pre-made coordinate plane to use where everything's going to come out perfect. We're going to do this the way that a lot of you might be doing it, which is just on like a regular piece of paper where you have to structure your work and do out all the steps to it. So we'll see how long it takes. I'm going to be explaining it as I do it. So we're starting at about like a minute 20 into this video. So I'm going to kind of color code these first. So we'll talk about this as being the red equation, and we can graph these two different ways. We can build a table, or we can put it in slope-intercept form. And I'm a fan of slope-intercept form, and I think it's better for this kind of problem because slope-intercept form will give us as many points as we need. Like we can keep counting the slope over and over and over again, where when you're building a table, the only way to get more points is to keep plugging in more numbers. Now, to get it in slope-intercept form, we need to get the y by itself. So I'm going to start by adding x to both sides. Negative x plus x is 0, leaving me with 4y. Now, you can write negative 4 plus x, but remember, slope-intercept form is typically y equals mx plus b, where the x is the first term you see there. And so instead of doing that, I am going to write x plus negative 4 or x minus 4. Either one of those would be fine. We'll go with plus negative 4. Now we'll divide both sides by 4, and that 4 divided by 4 is 1, leaving me with just a y. And right here, okay, I'm going to do something right here, and then I'm going to explain it. Okay, that is a 1 in front of the x there, so that's 1x divided by 4. And essentially, the 1/4 pops out of the fraction there, and then negative 4 divided by 4 is negative 1. Now, what I'm going to do over here, and I will erase this, is I will have students that like they can copy what I did there, but don't really understand why it's okay. Like you have the x in the numerator, and then the x is suddenly not in the numerator, and it feels like that should matter whether something is in the numerator or not. So let's go through that. We'll go through it fairly quickly. So we established that x is really 1x, which is where the 1 comes from. Now, suppose you were to back this up a step. You could write that as 1/4 times x over 1. Okay, so think about that as if you were multiplying the fractions. If you were to do that, then you'd multiply the numerators, and your numerator would become the 1x. So the x we know is sitting in the numerator, and then 4 times 1 would just give you the 4. Now, x over 1, though, anything divided by 1 is just x. Okay, and that's what causes it to kind of drop out of the numerator. Is that like you have a denominator of 1 there, and so it's just 1/4 times x, and that's how that x ends up where it is and how you kind of draw that 1/4 out. This is the kind of thing that if your teacher does it in class, or if I do it in a video, please drop a comment, raise your hand, ask your teacher. Like, don't just start doing stuff with the arithmetic and the fractions without being really sure as to why it works. But that's why, and you'll see me do that in future videos. Like that is one of those things we do a lot. So you can probably hear me racing. Okay, now let's look at the blue. graph, okay? And so we're going to put this one in slope-intercept form. Also, this one's going to be simpler, okay? We're going to subtract the 2x. 2x minus 2x is 0. And then same deal with this. I could do -10 minus 2x or plus -2x, but I want that in slope-intercept form, so that's going to be -2x plus -10. Okay, and that one's a little bit more straightforward. Now, for the graph on this, okay, I'm going to make this as nice as I can. Now, I could do a better job at this if I were doing it on a piece of paper, but I can't make it perfect, okay? When you're eyeballing your graph, it's not going to be perfect, but you need to make an effort to make it reasonably good. Okay, you don't have to bust out a ruler and measure every single tick mark. 3, 4, 5, 6, 7, 8, 9, and I'm going to need 10 down there. But you can't really rush through it either. Okay, so just and make an effort. All right, so for the red graph, we have a y-intercept of -1. There we go. And a slope of 1/4. So I'm going to count up 1 and right 1, 2, 3, 4. And what I'm going to do is do that several more times. So up 1, right 1, 2, 3, 4. And now I'm going to go down 1 and back 1, 2, 3, 4. Okay, I'm going to go back that way because to do this, 1, 2, 3, 4, put me over here. I need the nicest line possible. Okay, like accuracy matters, and I'm not being as accurate as I would love to be, but all right, second one, we have the y-intercept of -10, and this is a slope of -2. Now I could go down 2 and right 1, but that does take me off the bottom of the grid, okay? So you could do down 2, right 1, but what I'm going to do is this little magic here where I just say, you know what, I don't have space, so I'm going to go up 2 and left 1, because that's going to keep me on the grid. So up 1, 2, left 1. Up 1, 2, left 1. Up 1, 2, left 1. Up 1, 2. Aha! Yay! Okay, I found it. Found the point we wanted. Up 1, 2, left 1, and I'm going to stop there. And connect those. And we are looking for the point that makes both of them true, which looks like it will be that point right there. And fortunately, I do know where that is. That is -1, 2, 3, 4, down 2. So -4, -2, or you might write x equals -4, y equals -2. So that took me about 6 minutes, 20 seconds to do. That was all of it, and included like a little bit of a sidebar on what are we doing with those fractions. So we'll say in the ballpark of 5 to 5.5 minutes to do that one problem from beginning to end with all the explanations. It should not take you tons longer, maybe a couple minutes longer. So if your teacher gave you 5 or 6 problems of this type to do by hand, it should be looking at 35 to 40 minutes worth of homework if you had to do the whole thing. This will be speeded up if you do have graph paper, if you've got a ruler, like all of that will speed up the process. Now, the rest of the problems here are to be done using a graphing utility. So we have this one here. And again, the intent when you were doing it was that you would use a graphing calculator or hop on over to Desmos. If you don't have a graphing calculator, that is free. They also have a great app for your phone that you can download if you don't have access to a computer. But here we go. These are the 2 graphs. You can just type them in as is, and they appear to intersect at the point for -1. And of course, we could say x equals 4, y equals -1, or you could go and check those. So we can do like a quasi quick check. So we have 3x plus 4y equals 8. So 3 times 4 plus 4 times -1. That's 12 minus 4 and 8. Yeah, so it works for the first one. And looking at the second one, so 4 minus 2 times -1. negative times a negative would give me a positive. Now, what might help you see that is that's really a plus -2. So it is -2 times -1, which is +2, and 4 plus 2 is 6. And so you can verify, yes, that works. You can also do that with the ones you do by hand, especially if your graph is a little shaky. All right, this one was intended to stretch you a little bit. So this one is not 2 lines. You do have a square root there. The blue graph there is the one that is the square root graph. So you'll notice that it's not a straight line. It's definitely curving a little bit. It also just cuts off, so it doesn't keep doing whatever it was doing. So it's a new shape graph. Likely you've never seen it before, but it doesn't change the math. You're still looking for the point of intersection, which in this case is the point 4, 3. And again, you should be able to check that. So 3 is equal to the square root of 4 plus 1. The square root of 4 is 2. And so you get 3 is equal to 3, or 3 is equal to 2 times 4 minus 5. 2 times 4 is 8, and 8 minus 5 is 3. And so you can see, like, yes, that works for both. So it is the solution to a system. And the last one is not asking you for what the solutions are. So make sure you're always reading that. Now, this is one that you would do on a graphing utility. In Algebra 1, you probably typed in that SIN, you're just kind of typing it in and like, I don't know what this is going to be. And then you get the cool looking squiggle thing and think, ooh, that's cool. I'm doing awesome math now. You haven't seen that? That is usually, that's a function that you would study, or an equation you would study in maybe Algebra 2 and often in pre-calculus. So it's way beyond the scope of Algebra 1. But the system piece of it is not beyond the scope of Algebra 1, because math is consistent and the rules follow and those key concepts don't change. So if you go and graph them and you're asked not what are the solutions, because if you notice, they don't seem to intersect in nice places, all right? But what you can see is that the blue graph and the green graph intersect 3 times. So this system has 3 solutions. Finding out what those solutions are is a task for another class, but how many solutions, that you are totally equipped to answer. Common mistakes that I see students make with that is that they tend to look at X and Y intercepts and not just the points where the 2 functions or equations graphs intersect. So that's the answer to that one, is just 3. How many solutions? 3. What they are, weren't asked for that. Okay, that's it. Don't forget to like and subscribe for more math help. Drop a comment or question below if I did something that looked a little bit like math magic. Okay, we don't want to do magic. It's magical, but it's not magic. And check out some of the other content on the channel. I will see you in the next one.